All right, guys, so we've talked about how to do a very simple ANOVA. Now let's talk about how to do an ANOVA that's a little bit more advanced, adding in another variable. So for this example, I've created a vignette and a data set. And so let's have a vignette that's somewhat similar to our repeated measures ANOVA. And let's say that we have patients with anxiety that are seeking treatment, and we want to test a new drug for anxiety. And let's say there are 2 doses of the drug that we want to test. So treatment 1 is going to be 5 milligrams of this drug, and let's say the second treatment is going to be 10 milligrams of the drug. And we want to have a third group as a waitlist control, so a group of people receiving no treatment so that we can compare the effects of the drug to that waitlist control. Okay? And so let's say we also want to examine sex, because let's say that we have reason to believe due to it could be anything as far as mechanisms, hormonal reasons, body size. Let's just say that for whatever reason that we think that one treatment may work better for men and another treatment may work better for women. So we have our data here. We're ignoring patient. Again, this is just to signify in Excel that these are all the same person. So like patient 1, the anxiety levels, treatment group, the sex, that's all one participant. 2, 3, 4, it's the same kind of deal there. So let's say that we want to measure these patients' anxiety levels on the Beck Anxiety Inventory, which is a scale that measures severity of general anxiety. And so we want to run an ANOVA to look at the means of anxiety between these different patients within their treatment group, okay? Now, because we are not measuring anxiety at a pre-treatment and post-treatment level, we're just measuring anxiety after taking the pill, we are wanting to run a regular ANOVA as opposed to repeated measures ANOVA, because these are between subjects. We're not measuring the same people pre and post. It's just patient 1, patient 2, patient 3. Everyone's getting measured at the same time. Okay? So we want to go to ANOVA, select regular ANOVA. And so our dependent variable here is going to be anxiety. So we're going to move anxiety to the dependent variable box. And then our independent variable is going to be treatment. And we're also going to move sex here, okay? We're not putting sex in WLS weights. We are going to ignore WLS weights in this class, okay? So let's take a look. So what this is telling us, if we look at our p-values, there is a main effective treatment because our p-value is less than 0.05, which is our alpha. Now it looks like as far as sex that there is not a difference between men and women in their anxiety levels. However, when we look at an interaction, the interaction between treatment and sex on anxiety, there is a significant difference. So what does that mean? Well, let's run a post hoc test as the next step to see where these differences are. So we're going to go over to post hoc tests, and we're going to move treatment and sex to the box on the right. 2 key is checked. And so what we see here, we see our different groups. Now 0 corresponds to our wait list. 1 is our treatment 1, remember that's 5 milligrams. 2 is our treatment 2, which is 10 milligrams. So what this is telling us here, that as far as treatment, when you compare the wait list and treatment 1, 5 milligrams, there is a significant difference in anxiety levels. We see the same thing when we're comparing the wait list to the second treatment, 10 milligrams. There is a significant difference in the means. However, when you compare treatment 1 and treatment 2, we see there is not a significant difference in the means. Now that does not necessarily mean in this case that treatment 1 and 2 are equal for all people, because remember, we are also looking at sex and if there is a difference between men and women and how they respond to these treatments. So let's look at sex. Now this is interesting because we see here when you compare men and women, we do not have a significant difference, okay? Because what this is telling us is that men and women in this data set do not have a significant difference in their anxiety levels, okay? However, because we saw up here that there is an interaction between treatment and sex, that is telling us that perhaps there's something going on as far as the type of drug and how men and women respond to it. So let's look at that visually. And so we're going to go to descriptive plots, and we're going to put treatment on our horizontal axis Sex is going to go on our separate lines, and we're going to get this plot, okay? Now, how do we interpret this? So we see our treatment groups at the bottom. We've got 0, that's waitlist control, treatment 1, 5 milligrams of our medication, and treatment 2, which is going to be 10 milligrams. Now, for sex, let's say that 1 is male and 2 is female. And over here, we have our anxiety levels. So what's happening, we see in our waitlist group, men and women are more or less about the same, and that is backed up by the fact that we look at our post-hoc comparisons. There isn't a difference in the means of anxiety levels between men and women. Now that also applies to our treatment 1 and 2 groups, because if you were to average these out, there also wouldn't be a difference, because more or less if you were to average men and average women, it would be about the same for these groups between those two sexes, okay? But we see we have an interaction effect going on here. And what that means is we see, okay, so if 2 is female, it looks like females responded really well to that 5 milligram dose. And although they still responded to the 10 milligram dose, they did not respond as well as men did, and they did not respond as well as females did to the lesser dose. Males, however, although they did respond to the 5 milligram dose, they did not respond as well as females, and they also responded better at the 10 milligram dose. Okay, so that's what's going on here. And right here, when these two paths cross, is your interaction. Now, it can be a little bit misleading when you look at a graph like this, like when you're looking at a plot and you see lines connected to other lines, because that almost seems to imply that you're examining these effects over time, but that's not what we're doing here. These groups are all different people between subjects measured at the same time. So these are just different groups of people. It's not saying that, you know, anxiety was high and then that led to low anxiety, which then led to higher anxiety. No, these are different groups of people. And so although we didn't measure anxiety at pre and post treatment, we can make the assumption that, okay, if we have people that are seeking treatment for anxiety, their anxiety levels are probably pretty high, and we've assigned them randomly, which would suggest that we can assume that if these two groups had not taken the drug, their anxiety levels probably would have been about the same as our waitlist control right here. Now, you may also be asked to generate the descriptive statistics for the data and plot histograms. So let's look at how to do that. So we want to go to descriptive statistics, and we want to move all our variables, again, we're ignoring patient, to the variables box. We are not putting anything into split, okay? Now let's go to plots, and we're going to check the box, display distribution plots. And now we have our descriptive statistics, which we see shows our mean and standard deviations for each of these variables, as well as our histograms. Now, of course, the histograms for treatment and sex are not going to be interesting. They're going to be unimodal because they're just groups here as far as frequency, because we have the same amount of men and women and the same amount in each of our groups. However, what we're interested in is the frequency of anxiety scores, and you want to be able to describe the shape of this histogram. In this case, it looks like we have a slight skew, but for the most part, it is relatively normal. So here we have it. This is all you need to know to generate outputs for an ANOVA. We have our ANOVA analysis, our post hoc tests, our descriptive plot, our descriptive statistics, and our histograms. Thank you all for watching, and I will see you in the next video.